Hello everyone, today we're looking at the topic of combinations. And we're going to look at the ways in which you can arrange different things, for example, different numbers when you can't use the same number twice, or in scenarios where maybe you can use the same number twice as we see in front of us. So right in front of us over here, I've got three numbers, and I just want to write these numbers down in as many different ways as possible. So making as many different three-digit numbers as possible. So we could start with the number 1, 2, 3. That's one option. We then write 1, 3, 2. That's option 2. We could then try 1. We can do one again. We'd have to go 2, 1, 3. We'd go 2, 3, 1. We'd go 3, 1, 2, and we'd go 3, 2, 1, as we can see here. Now, from this, we've only managed to create 6 different combinations. Now the question I've got next is what would happen if I added a fourth number over here and I then added a fourth number over here and tried to make as many combinations as I could over here. So we made 6 combinations from the first scenario: 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. If we added another number, the number of combinations we would create, you will be able to see over here. What I have over here are all the different combinations you can make when you add a fourth number. Now this would take quite a long time to write out. There are actually 24 different combinations. These ones in pink are the ones which start with number 1, orange start with number 2, green start with number 3, and red start with number 4. Now there is an easier way of identifying how to figure out the number of combinations which we have. If we come back to the previous example over here, where we only had 3 numbers available to us, let's look at the numbers which you can have to start with. We can either have 1, 2, or 3. So that first number could have 3 possible numbers. Once I've chosen the first number 1, I've only got 2 options left. So whenever I've chosen that first number, I can only have 2 other options. So there's 3 options I could get over here and 2 options I could get over here. Once I've chosen the first one and the second one, I only have 1 number that I can choose left. And if I multiply these values together, 3 times 2 times 1, I end up with a value of 6, which is how many combinations I have over here. Now, if we apply that same logic to the scenario on the right hand side, well, the first number could either be 1, 2, 3, or 4. So there are 4 combinations for this first number. Once I've chosen the first number, I could either have 2, 3, 4, I could have 1, 3, 4, 1, 2, 4, or 1, 2, 3. I would have lost out on one of the numbers already. So there'd only be 3 options for the next number. Now, once I've chosen the first 2, that means 2 of these numbers are gone. I've only got 2 numbers left to choose from. So this gives a value of 2. And then finally, well, if I've chosen 1, 2, 3, or 2, 1, 3, or 3, 2, 4, I've only got 1 option left at the end, which is the number 1. So if I multiply 4 times 3 times 2 times by 1, I get the value of 24. And this is very much the case with all these questions. You need to look at how many possible combinations there are for the first number, then how many are left for the next number, and the next number. So, for example, I think a very, very common question which comes about, which I've seen, is let's imagine I had the numbers from 1 to 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So I've got all these numbers. And I wanted to make a 3-digit number like we have over here. Now, when we think about this exact same method we've done before, the first number has a potential 8 options it could be. So the number of combinations we could get starts with 8. There are 8 different options for the first one. Once I've chosen one of these numbers, let's say we chose 8, I only have 7 possible numbers left behind afterwards to choose from. So the next number over here, or the number of combinations I've got or options I've got next, becomes 7. And then once again, if I've then used up 2 of the numbers, so I've used up one number, another number, I've only got 6 numbers left to choose from. So to work out the value or the number of combinations I could get, it would be 8 multiplied by 7 multiplied by 6. And if you do that on your calculator, you get a value of 336 different combinations. Okay, so now that is a scenario where you can't use the same number twice. So what we're going to look at next is a scenario, which I think in real life you come across, where you can't use, or you can use the same number twice. And a very, very common example of this is, for example, a padlock. You might see these combination padlocks where they have the numbers from 0 to 9, and you then have maybe 3 numbers in which you can fill in. So if you think about this, as we saw a moment ago, we had 3 possible numbers that these can be. Now, the way I like to teach this, or I like to show you, is let's imagine we only had 3 numbers. Let's imagine we only had the numbers 1 to 3. And I was going to put them into this box. And with a padlock, you can use the same number twice. So over here, I've got my 3 numbers, and I'm only using numbers 1 to 3. These are the possibilities I can have. These numbers beginning with 1, these are the numbers beginning with 2, these numbers beginning with 3. Now, if you count up each column, there is 9 numbers here, 9 numbers here, and 9 numbers here. That makes a total of 27 different combinations. Now, we're just going to apply the same logic we did a moment ago for this question as well. We saw if the first number is 1 or 2 or 3, there are 3 possibilities over here. Now, once I've chosen the first number, there's still 3 possibilities for the second number. So that's going to be 3 times by 3. And then finally, the third number is also 3 different possibilities. So that gives me another 3. And if I multiply this together, 3 times 3 times 3, I get a value of 27 different combinations. So this is a scenario where you can choose the same number as you had beforehand. So let's bring it over to here, to our padlock on the left. Now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different options this first one could be. The second one could also be 10 different combinations because you can use the same number twice. Finally, over here, this is also 10 combinations, which means that the total number of combinations, if you've got 3 different pads or 3 different combination points, gives a value of 1,000 different combinations. That means if you've got a padlock with 3 of these different things which you can twist, that means you could have 1,000 different possible combinations. If we added a fourth one, there was a fourth one, well, there'd be a fourth box, which means you'd multiply that by 10 again, meaning that there would now be potentially 10,000 different combinations that you could possibly get with a padlock with 4 of these things or 3 of these things comparatively. So just as a final question, what I'm going to ask is this, and that is, if I flip a coin 5 times, how many combinations will there be? How many combinations will there be? Now, if you flip a coin, there are only 2 possible outcomes when you flip a coin. You can either have heads or you can have tails. So if we think about this, I'm going to draw my 5 boxes. Now, these boxes could either be heads or they could be tails. So in each scenario, the first value, there are only 2 possibilities. So there's going to be 2 possibilities for that, just like we had here, 3. There are now going to be 2 possibilities for the next one, 2 possibilities for this one, 2 possibilities for this one, and 2 possibilities for this one. That means the total number of combinations I could get could be 2 times 2 times 2 times 2, which gives us a value of 32 different combinations. If you don't believe me, write them out yourself, and I guarantee that is how many you will get. But that's it for today. I hope you've understood the method. If you haven't, please leave a comment below or message me directly. Thank you very much for watching. Take care and goodbye.